Okay, so if you take a look at the whole sheet here of electrochemistry review, you got to balance some redox reactions. I'm going to have some sort of an image. It will not be this one. There's already one part I don't like. I didn't make this image. It's a little confusing. Can you label things? Can you answer some stuff on a pre-made drawing? Can you tell me about some spontaneity issues? Can you do a conversion of some sort on the back? Can you do some simple work from a set equation? And then, can you give me a whole lot of information from hardly anything? Which means that, can you draw an entire voltaic or galvanic cell based on me just telling you what two elements there are in there? And you can. We already did it today. So, it's going to be kind of you and me. I'm not just doing this for you. So sometimes I'll give you some time, and if that is the case, I usually pause the video so then people aren't sitting in their living room like waiting 7 minutes and not knowing what's happening. So we're going to start in this one, A and B. And what I'm going to do is I'm going to give you the opportunity, without me starting it all, I'm going to give you about 5 minutes, let's say, and see how far we get on these. If you have some questions, you can definitely ask. I will go through how to do them. But me just doing it, that's not going to help you. So act like this is the test. I'm going, I'll be up front. You're going to get one of each. Like that's a guarantee. You're going to get one of each. It cannot take you 30 minutes to do two. It just can't. So start balancing those out. If you want to compare to people, definitely can. I'm going to pause this. So if you're watching this, unpause it when you're done. So I'm just going to do the first one here. I know you're working on it. But if you're feeling like you got it when you're done, you probably don't even need to really watch. But it's always nice to get it kind of confirmed, I think. So I'm going to split them, and I'm going to get going on mine. That was a minus. I hope that didn't mess you up. There's a little negative there. So I got to balance everything that's not a H or O. There's not an issue on any of those. So no O. If there's no O's or H's on a line, that is awesome. It's going to be a lot less work for me. I come down to the second line. I need 3 waters, with 3 O's. Now I balance my H's. I have 3 plus 6. So I have 9. Looks like that should all work out so far. Now what's left? Electrons, okay? First one, I have 0 and 2 plus. So I hope it makes sense that I'm putting 2 electrons on the right, because that makes it 0 again. I am praying that it's on the left. I have 0 here. I have 9 plus and minus 1, so that's plus 8. So I need 8 electrons on the left. 2s and 8s make me feel good, because that is something that I can manage by just multiplying this by 4. I add it all up, and I should get that. Hopefully you got it. On the test, I look to see if you've done work, and then I look at the answer first. If the answer is right and you've done work, you're good. I'm not going to go through every single thing like they didn't cross it out the way that I would have crossed it out. I mean, you can't get to this without doing it right. Then I have to dissect it. If, God forbid, you made a mistake, that is actually hard to find. It's like, where is the mistake? And I got to figure out what that is. So basically, you get points for, did you understand to balance everything besides an H or no? Did you use H2Os to balance your O's? Did you use H pluses to balance your H's? Did you do the electrons correctly? Those are where the points come. Okay, so that's how that would go. All right, second one is harder. Basic one is always harder because there's just a little bit more. So hopefully, if you're not done, or if you are, you were heading in the right direction. So. Where? This one? Yeah. You tell me. Better question, doesn't matter. No. It does not matter because I don't care which order I put it in. Okay? Like it does not matter at all. But this went up in charge. So this one's the oxidized. That one's the reduced. Because the tin's going up. This is 0. This has to be a positive because this is negative 4 right here. So this would be plus 1 plus 2 would be plus 3 minus 4 would be minus 1. It doesn't matter. I'm not going to make it. I don't care. I don't care. Whoa, trippy. Okay. we go. Don't balance OHs. That has O's and H's in them. So shoot, I thought it's kind of funny. Actually, when I was putting this out here, my mind went somewhere else. I thought we had something that we had to balance. So be careful. You got to double check it. So COs and SNs look good. So now I need one HO, or one O, I mean, sorry, H2O. I need two H2Os. I do see some of you do not do it like in steps, like you do it all the way and then you start over. That's not wrong. It's how your brain works. Mine works where I want to just do the waters and I don't want to forget that I didn't do it on a problem. It's your call. I have three H's on top. I have 2 plus 3, 4, another 2. So I have 4 H's over here. So I need one H plus here. If I'm doing something wrong, or if you feel like that wasn't right, speak up before I go too deep ever, because I haven't done any of these problems before. I put them all together less than an hour ago. I have 4 here, I only have 1 here, so I should have 3 H pluses. There's no rule that the H pluses have to be on opposite sides or anything. The only rule ever is the electrons. You have choices, you can add electrons right now. I don't suggest it. So if I'm not going to do electrons yet, what's the step I have to do right now? OHs. And on the test, a mistake with that would be that you only do it on one side. You need to do it on both. So here I would need an 8 OH. Why 1? Because there's only one of these. Right? And if it's really crammed, figure it out. But make sure it's obvious. And here I need 3. They have nothing to do with each other. I would strongly suggest writing below if you were running out of room so you don't lose it. Like that stands out big time. I'm still not done. So if you're really crammed for space, make sure that you've given yourself enough room to be able to do this. I can cheat because I have smartboard. So now I have to figure out my electrons, and this is the hardest part usually. Sometimes though they work out nicely. Why this one? 0 charge. -1 only, that's why I'm not seeing something. So all I need is a 1. I need just 1 electron. That's it. I'm praying the electron's on the other side. You need to keep telling yourself that. You just can't blindly go through it. I have 3 negatives on the left. I have 1 negative on the right. Sweet. Because 1 negative gets down to 3 negative. So I need 2 more electrons. Is this matching up to what people have done? I hope. So what do I have to do? Take the top. Multiply it by 2 and exaggerate. Oh, huh? What happens there? I mean, I can do it now or later. My H2Os cancel out, right? So I'm just going to get rid of them now. I'm not going to worry about that. I didn't think about it until here. And then this one, these are gone, and I'll just have one of those. Add it all up. I hope this is what you look like. OH minuses, I'm going to add. That one's gone. There's only 1 left. And there's just more to do. That's all. I said this this morning, I think. It doesn't matter where you do in the order, but I would really stay in one line, then drop to the other. And then I like to drop to the other side of it and then drop up. Did I miss something? Yeah.
Oh, okay, so for the OH2 and the OH3, I'm like just balancing the waters that can add the H2O. First, is it okay? I got the same answer, so I'm just adding 3 H2O on the other side and then 2 H2O on the other side. Is that okay? Does that make a difference?
No, but you eventually bring it down and you got to cancel it out and end up with 1 H2O.
So it ends up with the same answer.
You can't have H2O on each side though. In your final answer, you cannot have H2O on each side.
Yeah, I know. At the beginning.
Like the blue parts when you're balancing the O's.
Yep.
Yeah, I canceled them out by adding 2 H2O to the left side and then 3
This
H2O
one?
to the right side.
On the top. Yeah. Since there's 3 O's on the left and 2 O's on the right.
Is it okay if we still got the same answer? Like, does that make a difference?
Yeah, you just brought more on each side, which will then reduce it again. I would really be careful though. You're just trying to balance your O's.
Okay.
Like you don't need it's 2s and 3s. You just need 1 more H2O to make 3 H2Os on each. There are 3 O's. I get what you're saying.
Yeah.
If that works, or if that somehow makes sense, like in your direction, I feel like you're actually putting more into it. Like I want to do as little as possible, so I only want 1 more O, so I only add 1 more H2O.
Okay.
Did we get this? If we got these, I mean, the only thing I regret and I feel bad about it is that we don't have one that you had to start with adding, like maybe this was cobalt with a 2, so you had to put a 2 in front to make something that wasn't balanced. And just be careful on that, okay? Besides that, these are pretty good examples. All right, moving on. So I found this on a worksheet. It's actually a very old one. If you look really carefully, it literally is photocopied off of some like exercise. But it says the diagram below represents a galvanic cell involving zinc and copper. Okay. Match the numbered items in the diagram with the letters on the left. First, I would like you to correct one thing. I don't like how this is written. So I would like you to have an arrow from this circle on going towards this electrode. So I don't want the arrow coming where it's coming from. Like this is showing where this is going or coming from. I want this one to be doing that. So if you want to add that, like literally just what I've written here. So what do you need to do? You need to label all this, but nothing's been said. It does tell you the direction of electron flow, which is nice. That's information. But what's something, anybody, thoughts? What do I have to do to, I mean, can I just start labeling? Nothing's labeled. How can I actually know? Like, there's a wrong answer. Like, well, I'll just name this one that and this one that. There are certain right and wrong answers. Evelyn? The reduction potential sheets, yes. So, I'm going to give you a minute. I'm going to pause it again. I want you to start figuring out. And if you're not sure on that, you need to talk to others or yourselves. Talk to yourself. And you need to figure some information out. So, take a crack at it, and then we'll start placing stuff. We are kind of do this actively together. So I hear people starting to find things. Does not matter the order that you found it in, as long as you find them both. Why do I know it's a 2? Oh, I thought I heard somebody whispering it.
For the CU, since there's 2 CU, 2 plus, do you use the one that matches the other electrons?
No, if you look closely on that one, Max, underneath that Cu2 plus goes to Cu plus.
Oh.
And when you see this picture, hopefully you recognize that there's an actual solid piece of metal. Okay, that's a big deal. So this isn't a secret. You have it in front of you. This is 0.34, I believe. I hope I'm not flipping these. Is that right?
Yeah.
And negative 0.76. Right. So, which one has to be flipped? The zinc. Okay. The minute I flip the zinc, is that being oxidized or reduced? Just based on what this sheet is. Oxidized, because this is a reduction potential sheet, right? So this one is oxidized. Why am I talking about that? Because maybe you could use oil rig. Oxidize involves loss. Reduction involves gain. Shouldn't that tell me the flow of electrons right there? Where are the electrons going to? Who's gaining them? Oil rig. Who's gaining them? Copper. Shouldn't this be my copper? Oxidation it involves loss. Reduction involves gain. We're saying this top line is oxidized, so oxidation involves loss. So the zinc should be losing it. So what I'd like you to do right now, do the best you can. Hope we can get it right. Label 1 through 8 with letters on the right. So use these A through H. And you can place them 1 through 8. You get it? Hope that makes sense. So lay it all out, and I probably gave you more information I should have already by writing those 2 symbols up there, but that's kind of the mindset. So again, I'm going to pause it if you're at home. So let's do a little process of elimination. Help me out with some of them that are easier. Max, give me something. 1 through 8. 1 is C. So you're saying that's the cathode? That's the cathode because a red cat is reduction, right? Does that correspond to what we did? Yes, it does, right? N-ox, anode, is oxidation. Reduction is a cathode. So let's go off of that. A 7 would be hopefully E, I hope. I mean, I hope you commit at least, like if, unless you totally don't know, I'll say this actually though, on like an AP exam, like in May, they won't allow you to put C and a C or E and an E. You're like, I don't know, but I'll put them both and then I won't lose the points. They actually, you wouldn't be able to get any credit, you'd have to commit. But on something like this, you better just, at least those better be the only two options that you have. So, Ashley, what else you got? Anything?
The number 2 is H, that's copper solution.
Sure. H, you said?
Yeah.
I agree. You got, Tessa?
8 is A.
Good. Jordan, give me something else.
There's 3.
3 is B. Yeah. And that's kind of weird. You're like, wait a minute. Like, you broke it down that much. Again, the other one, I actually have more directions and flows. Like, you would actually have to tell me which one's the anode and or the anion and the cation or something like that, which we talked about. This one shouldn't, to finish up, this shouldn't be that hard. I'll give you 4. 4 better be the U2 on that. It's holding the salt bridge inside. So, B. This one shouldn't be all that complicated. There's not much left. Why did I have you draw this on here? Is number 5 is the zinc cation because it's going onto the zinc metal. Oh, that's why. Okay. Oh no, sorry, copper cation. No, I got scared because I took this and actually changed what the metals were. So whew, I'm like, oh no, I did not change them all because they had a different metals on here. This would be, because we said this was copper, sorry, that would be the copper cation. What number is that? 5? And that's the zinc cation. But the reason why is that this is coming off and this is going onto it. So you could also, I could ask some other questions. Which one would be fuzzy? Which one would be gainy? Which one would be plated? The copper or the zinc? Copper is plated. You might even want to just draw that for yourself. Right? That would be the plated. This would be the one that would be losing. I mean, there's all that stuff that we can be doing, okay? Let's move down to the bottom here. Write the equation for the half reaction that occurs at the cathode. Is this an explanation? We've already talked about it. An example of oxidation or reduction. So let's just fill these out. You should know. I literally have it written up there. What is the equation for the half reaction at the anode? And then give me the overall ionic equation. This shouldn't take more than a minute because it's already all established on the top. Like we've already done it. And labeling a photo or a picture is not all that complicated. You just need to make sure that you slow down. And to be honest, how did we figure it out? It's really about the voltage and figuring out the flow of electrons based on the chemical equation. Once you know that, everything's good. But you have to know that or else everything would be backwards, like everything. So that's the most vital part of all this. So not that I'm worried about time here, but who's at the cathode? I know we have letters, but if you're not thinking of it too hard, the zinc or the copper? Who's involved with the cathode? Copper, okay. So hopefully we're writing it in the proper way now. This is written all like this, but we haven't talked about this completely. I flipped this one. So this is the equation for the copper. I hope that you went and you switched this to the zinc. You did not flip it, that's wrong. And I bet a lot of you did not. They cannot be on the same sides. Okay? The one that was not flipped has to be reduction. Besides the fact that reduction involves gain, and you're gaining them, I think the just common sense of it all is that these are reduction potentials, and you didn't flip them. So you used it as is. And as is on our sheet is a reduction. If you have to flip it, it automatically becomes oxidation. And why is it oxidation? The oxidation involves loss. It's being produced. It's being created. It means you're losing it. So, overall, our ionic equation, hope that it would make sense if we're just putting these together. What's the thing that has to be true, though? My electrons do have to be equal, right? So if they weren't, I'd have to double or triple, or if there was 2s and 3s, double and triple each equation properly. But what does not Like there's something missing in this. What does not carry through are the electrons. Cannot have electrons written in here. So that would be my final equation. So that is that. All right. Take a moment. This shouldn't take more than a moment, though. Number 12. Is it spontaneous? There'll be a couple like this. It's not a lot. I don't want to spend too much time. I don't think this should be worth that many points. But you should be able to tell me. And I will not help you. You cannot ask me. I don't get it. Well, how am I supposed to know it's spontaneous? I don't know. How are you supposed to know it's spontaneous? When I say show some work, what I probably will write on a test is show me values. I should at least see some values. You should be able to write a few values. Suggestion, here's a good way to do it. And you actually just write the values associated with those pairs, those pairings. Now, I actually don't know if this is spontaneous or not. I just picked two that were on the sheet.
Do the big numbers in front of the letters?
The coefficients?
Yeah.
They do not. No, that's a great question. Those are just there because they're balancing based on the rest of the equation. But the actual half cell reaction does not have any effect. Good question. So, I hope you found something. And it doesn't matter how you write it. Wow, I can't find it at all. On the sheet, I'm not trying to confuse you here. The aluminum one, as is negative 1.66. And then the hydrogen one, you know it? Is it 0?
0.
Why did I pick that? Now, as I'm saying it, I'm like, no, that can't be. I didn't pick the 0. It's okay. Still helps. All right. Is this one been flipped though? It still works. Did I need to flip that one?
Yes.
Okay. And the reason why you can also ask yourself, if you're confused or not getting this, it went from 0 to +3. That's going up in charge. That's oxidized. That's actually higher level thinking than just literally looking at my sheet and going, okay, does that match up? You know, oh, wait, the aluminum should be on the other side and the ion, they're on the opposite sides. Great. If they're on opposite sides, it should flip. Because of that, it's spontaneous. Okay. If you ever ask why, literally, the overall voltage is positive. Or the overall voltage is negative. That is why it's spontaneous. Spontaneous is not about, again, getting a hairstyle or going to Vegas or anything like that. It will naturally occur. It could take 1,000,000 years, but it will occur without any intervention. Like it just will happen. So I hope we can do those. I mean, if you can't do those, I'm amazed you can do other ones because it's more just a simple concept. All right, let's quickly do one T-chart. You will be required to do one of these tomorrow. How many grams of copper 2 can be reduced by applying a 3 amp current for 16.2 minutes to a solution containing Cu2 plus ions? Again, I'd like to give you an opportunity to try to do this. If you need your orange sheets, great. I don't think you will for something like this, but you may. If you can't remember it all, like get your orange sheets tomorrow. So I'm going to give you about a minute to get it set up. So see what you can do. If you're getting stuck, we'll talk about it. Like I believe it literally shows this, right? And then it's almost like not a sentence, but it shows something like, I mean, I'm doing this totally off the top of my head, but is it something like that in the lower right?
Yeah.
And it's not totally direct. Yeah, it basically says that. So you need to just understand what you're seeing. And the biggest thing that is a huge frustration is that this is what it actually means. Right? It's like, why don't you just write it? They used to. What do I start with? The minutes. Can anybody enlighten me? I talked about this today, but I don't know if I did both hours. Why do I know I don't start with the amps? Like, what's a huge hint? Or why, like mathematically, that would not work well?
You put minutes to seconds.
Okay, maybe. What else? Let's stay on units. Why don't I want to start with this unit?
Because you like the second, or,
Like when you can put that number in the coulombs over 1 second.
So I got to put that coulombs over 1 second. So why is that a problem with what I'm looking for?
how to get from the
How do I get from minutes to grams? Even more simple than that.
Second.
I'm starting with 2 units, but I only want to end with 1. You don't want to start with 2 units in any problem like this if you want to end in 1. That's a huge tip. Like always, like if you are looking for something with 2 units on top and bottom, you need to start with 2 units. If you don't want to start with 2 units, don't pick the one that has 2 units in it. Okay, so I'm going to fly through this because this part we should kind of have down. It's the second half that's a little trickier. I got to get it into seconds if I'm doing this kind of problem. It might ask, what is the amperage or the coulombs? You have 3 examples. I don't know what the title was called. I think electrolysis notes or something like that. There's 3 problems. Look at them tonight. That's a really important worksheet or a note sheet. Look at those 3. I did 3 different kinds of problems that would be all fair game. It'll be one of those 3. You have a 33% chance of getting one of those problems. Okay? So then I have seconds down here. In this case, I have the 3 coulombs over 1 second, and now everything just starts to happen. And I know this is very similar to other problems that we've done. They're all very similar. There's not a lot I can do. Here's the key. I think this is the one that people start to get a little shy on. It's not really about the ion. It is. It is about the ion. I should not say that. But it's not about your focus if you're worried about, do I write moles of Cu to moles of Cu2 plus? It's copper's going to give away a certain amount of electrons when it becomes an ion. An ion or an atom will weigh, in essence, the same amount. So I don't really care what I write here. Okay? Because then I'm going to write 1 mole Cu, and I'm going to put grams Cu. So what goes on the bottom here? How many moles? 2. Why do I know that? Copper 2. Okay, if it was copper 3, it'd be 3. I mean, just, well, why? That's positive. Exactly. It had to lose 2 electrons to become positive. And then copper, 63.5. And then I just multiply through. What I'm going to be focusing on, do you understand this area? Did you utilize this right? And especially that part, like that middle 3, that's going to be used somehow. Looking at those electrolysis notes as well, you're going to see how they're all utilized the right way. And it should work out pretty well. So I don't know the answer. You can easily calculate that yourself, though, I would think. Okay. We have 2 more things. I'll always get done by 4 or before, so we're doing really well. So here we go. Number 14 on our sheet. I gave you an equation. Write the cell line notation. So we're not drawing it all. And the last one we'll do together kind of quickly. But, okay. Can I just start writing them? Mg, Pb? No, Marco, what do I need to do? No.
You gotta find out which one's the cation. Or,
Yeah.
I'm sorry,
No.
cathode.
In the anode, right? So how do I do that?
You find the one that's flipped.
Yeah, find the one that's flipped. Perfect. Find the one that's flipped. You don't need the voltages, although, might as well find them, right? Might as well find them. So, you have a couple options. You could just do this. Which one is flipped? Without even looking at your sheet, which one's flipped? Mg, it's going up in charge, right? It's going up in charge. So let's find them. Write the voltage that's correct right away. Like it's been flipped already. So the Mg one you need to flip. Let's do that. I will find the Pb. You guys find it? 2.37? Pretty big difference. So, which one do I write first? Because it's NOx, right? Anode has oxidation. So it should be Mg. Once you know one, I hope we feel like then it just falls into place, right? I mean, it has to. You put the metal, you put its ion solution, you put the ionic solution, you put the metal. If you're like, whoa, whoa, slow down, I didn't understand how you did that. We flipped this one. This is being oxidized now. Oxidation involves loss. You're losing it. You're losing that. Electrons leave the anode. They go to the cathode. How am I going to remember that? A to C, AC, alphabetical order. I mean, I should be able to picture my cell on that note sheet. Like, look at that note sheet again, that electrochemistry cell, electrochemistry notes, the original one. This is everything. I mean, this is the beginning of it all. This is the base of it all. This binder right there. Right there. Oh, whoops, saw that. Oh my God, my life. How do you show your work? It's pretty simple. You don't need parentheses, but it's always adding, so just to show it correctly, that would be the best way to do it, or something like that. But you do need to show the numbers. If you want to put, I mean, the best way is, we've been doing this a lot, you put those two, the equations on each side, and then you have the voltages, and we add them up. You know that look? That's really nice. But we have a voltage, so what's that going to be? What? 2,4. Oh, I thought you said 3,4. I'm like, no. Okay, so let's do a little plug and chug. We need to do this once. So I gave it to you at the top, and somebody had a great question today. Wait, that's not the same equation. Sometimes it's a different number here. It might have natural log, and then there's a different number here. I will give you which one. Well, actually,
Oh, so you're gonna give us like that equation?
I'm going to give you that equation.
Oh, no.
Product over reactant. Let's look at it today. Let's look. So it says, if Mg2 plus concentration is increased from 1 to 2, what will be the voltage of the cell? What will it be? And assume that Pb is standard molarity. What's standard molarity? Meaning that it's the standard, if you don't know anything else, that's 1, correct? You might want to write that down, just so you know. Standard molarity is 1. You should know that. So this is what we do. I'm using this right here. I've been very upfront, so if that's good news for you and you didn't realize, I've been saying I'm going to give you that equation the whole time. So if you didn't know, hey, good news. So here we go. By the way, if you're actually writing, it's actually accepted to do kind of more of an E like this. If you're unable to do that, like your manual dexterity does not allow you to make curves, like you just are spikes, that's still better, okay? That's better than like whatever else you can do. Although I have a feeling it's not going to be that legible if you can't do that. Okay, this right here is what it normally is, the standard voltage, and that's right here. That's that. It's what it is under normal conditions, under standard conditions. Okay? All this number here is a relationship of 3 other numbers. Faraday's constant, the R value, and temperature. They already did the math for you. You don't have to worry about it. What is N?
2.
It'd be the number of moles of electrons, right? In this case, it's 2 because they balance out. Like, there's no coefficient, so they have to be exactly the same. So it's 2 log of, here we go. It's products over reactants of the ions. Check it out. It's already written here for you. The Mg is the product. The Pb is the reactant. It told me that Mg went up. So Mg goes on top.
Why is it 1?
Because Pb did not change.
Oh.
And now you literally plug and chug. You take 2, divide by 1, take the log of it. Multiply by that, divide by 2, and then take your cell and subtract it. I'd like you to try to do it.
Wait, I thought the product was solid.
Now these are ions, these are solutions. That is a product. These are both products.
Okay.
But it's about the solution. It's about the concentration of the solutions out of the metal.
Okay.
I cannot believe it. I just typed 2 divided by 1. Anybody else do that?
Now,
Oh my gosh. And I actually hit enter and then I go, oh, yeah, right. Stellar. Oh my gosh. Oh, I just did it again. I just did it again. I switched calculators. I'm embarrassed. this is what I got. I'm hoping someone else gets it, so I feel more confident about this.
I honestly, if I didn't know this, I would be in so much trouble.
Please, there are two. There's actually three things. Three. We're gonna list them all. I just want one. And if you can come up with another one, that's great. Give me one possible reason why the battery will eventually die. And I put in parentheses because it's not alive. What's one thing that could happen? An electrode runs out? Specifically, which one? The anode or cathode? I want to even be specific. Just here. The anode, right? The one that gets eaten up. So anode dissolves. Let's say that. You can put runs out. Right? Okay, what else?
The solution.
Margot?
The cathode solution gets saturated. Like, it can't dissolve anymore. I don't know.
No, you're close though. Cathode, it's the other way. Cathode solution,
Can be reversed.
too low molarity. Like the concentration gets too low, because that's the one, guys, that the here. It's better with the picture. That's this side. Whoops.
Yeah.
Sorry. Well, now it's this side. I wish we weren't looking. This is the cathode side. As this is constantly going on here, this is getting less and less, and if that gets too low, it dries up. Right? This is the one that this runs out, that runs out, it's dead. If this solution, because this solution is going to get more and more concentrated. If this runs out, this is never going to run out because it just keeps getting thicker. So if that runs out, great. What's one more thing on here? If it happens, the cell dies or it stops running. It doesn't work anymore. Yes, that's the one no one comes up with. Salt bridge. I'm just thinking about becomes disengaged. It's disconnected. No, it doesn't. It's never really gonna. But
Yeah, how does it like?
let's just say disconnected. An issue with a salt bridge. You're not connected any longer. Okay. Well, because there's all sorts of scenarios that can happen. with salt bridge. It might not be touching the solutions anymore. It might actually literally fall out. It could break open, and then also we're not allowing it to flow. There's all sorts of things that could come up. I'm only asking for one. Okay. I know we're getting close to time, but we're going to do this together kind of quickly. So last thing. Here we go. You help me get this started, and then we'll do all this. So it says calculate the cell voltage for the galvanic cell between calcium and cobalt-2 and their ions. Then draw an accurate diagram of the galvanic cell for the reaction. And then all these things would need to be in there. Okay? And you don't have to draw arrows. We're just going to draw, like, I don't want you to connect them. You'd actually write like anode or cathode or whatever. But can we do this? So what's the first thing I need to do before I can start drawing this? I need half reactions, right? I need voltages. I need voltages. So if you look these up, and I'm not even looking at any sheet yet. Oops. I'm doing it backwards, aren't I? Reduction involves gain. So these are the ones, I mean, this is what you should find on your sheet. I am praying they're both on there. And I'm going to quadruple check my stuff tonight. They are. Good. And I'll show a different, if you see an E, that works just the same. Just lost that one. Is that right? Yes? Am I wrong? Okay. Alright.
Wait, for cobalt-2,
Yeah.
why would it be the one at the top?
I don't know. Well, you tell me. Why isn't it the top, the second from the top? First off, it's 3+. Secondly, there's no metal. Like there's more specific situations that we'd have to talk about, which we're not getting to this first time through this stuff. got to be a metal and an ion. Okay. So it did say calculate the voltage. So my overall voltage is what? Good. Positive, correct? Okay. So you do need to know. I'm just gonna, for shortcut purposes, that's what's happening, correct? Like that's what's happening. So let's do a generic picture. You draw it. I'm not gonna draw anything. Can you start putting stuff out here? Actually, I'm gonna redraw this, like this top part, just so there's no confusion here. This is the final thing we're doing today. I think it's really important for you to do it without me at all. Can you draw this out? And then we're done. And then go through your checklist. So just draw it generically, and then go, okay, I'm going to label that, I'm going to label that, I'm going to go here. You might have to do a little bit of descriptions with words. If you've been wondering why I haven't been doing salt bridges, it's just easier to draw something with a porous plug instead of like a U-tube, I guess. There's just less to draw. That's all. So I'm going to go from the bottom. Oh, no, I'm not. Anode in the metal, cathode in the metal. So I need to actually label those. So who is my anode? Well, I'm going to try to make it this side. Maybe you didn't do this. I'm going to try to make this work. So if I'm forcing the issue, which if you didn't, and now you just place them, that's fine. What does the anode have to be? Oxidation, N-ox. So who is, oxidation involves loss. Who's losing the electrons? Ca. So this has to be Ca. So automatically this is Co. Right? Illustrate the electrodes losing or gaining mass. Who's going to be fuzzy? Who's going to gain? Co. This one's actually going to be losing. Metallic ions in solution. Oh my gosh, I hope that this is not the issue. This would actually be a really bad test question because Ca and Co, for those that can't write very clearly, just be like, why did you put Ca twice? I didn't, that's an O! It's like it's the exact same. I can totally see that after the fact. It's, oh, whoops. Illustrate electrodes, metallic ions in solution. Electron flow direction. Clockwise, counterclockwise. Clockwise. I appreciate those of you that do it on the wire. I really hate this. You just do that. Like it doesn't, it tells me like you don't, it's like it just goes. I don't know how. It's like a drone. I don't like that. Almost done. Cation and anion flow. What do I mean by that? Those I would be probably more specific if you're not sure, but those would be the electrolytes, right? So you could write it literally here if you want, but which way is that going to go? Positive this way? Good.
You know that again?
There's a couple ways. You could say the electrons are coming this direction, so positives go over here.
Okay.
More specifically, these ions are going onto the metal. These ions are going into the metal, so we're losing positives in solution.
Oh, yeah.
The solutions are getting under or overcharged. And then lastly, specific voltage. It's amazing, and I change these what I want all the time, but like, if you don't actually write it, and you write it right here, it's wrong. That's on a voltmeter. This box is a voltmeter. No, this is where you have to put it. Like, if you're just like here. Like, no, like, where's that? Like, it's up here, just like sitting on top. It's got to be in the actual drawing. I don't know how we feel, but if you're feeling like, you know what, I think I got this kind of down. If you know a weakness of any test, it's about as blatant as it can be. It's if I don't get this part, they're all going to be on the test. Every little part. If I don't understand this part or that, I need to know. So, our review is due tomorrow. If you need anything, you can definitely let me know.